So to begin our project, we're going to head over to start.spring.io and we're going to create a new web server. We're going to review some of the dependencies that we're adding into our project and to understand why we need them. And then we're going to create a REST controller and we're going to expose some endpoints that we can then test from the web browser so we can see how we can interact with our web server and receive responses from it. So if we take a look at the diagram that represents our application, in this video we're going to be creating that first Spring Boot web application, and this is going to be the server where our REST service belongs. We're then going to be able to make some GET requests into that server so we can see how it works with some dummy data, and then later on in the next two videos we're going to look at how we can connect it to a database and how we can persist certain requests and also get data. So to begin by creating a Spring server, we're going to head over to start.spring.io, and this is a typical way for creating any kind of Spring Boot project. So the project is going to be a Maven project because that is the build tool that I prefer. We're using Java, and at the time of recording this video, Spring Boot version 2.6.2 is the main one. Because our application is for a store, I'm just going to change the name of the group to com.store, and then the artifact will just be store. And the description I'll just change to REST service for store, and I'm just going to change it to Java 8. Now when we create a Spring Boot project, we need to add dependencies, and essentially a dependency is a further library that we would like to add to our project to provide some functionality. And one of the benefits of Spring Boot is that it provides a lot of functionality to us out of the box so we can get running really quickly and really easily. So the only dependency we're going to add is called Spring Web, and we can see from the description it says build web including RESTful applications using Spring MVC, and it uses Apache Tomcat as the default embedded container. So Spring Boot Starter Web will provide our application with tools such as the embedded Tomcat server, and that is going to be the server that responds to any of our REST API calls. It also includes Spring MVC, and MVC stands for Model View Control, and this is typically used for creating a UI component of our application, but I'll touch on this area a little bit further when we're creating our controller, but we won't be using any Spring MVC within our application. But the most important part here is creating this RESTful service, and this will allow us to send requests into our application and also to receive some responses. So to create this Spring application, you just need to hit generate down below, and that will be added into your downloads folder. I can then open this within my downloads folder, and I have this folder here called store. And now I'm just going to start IntelliJ, and I'm going to open up this store folder that we have. So I'm just going to select store from the downloads and hit open. So when we first open our store directory within our IntelliJ IDE, we can see we have this com.store.store package within our main folder, and we also have a pom.xml file down at the bottom. If I open this file, we can see that we have Spring Boot Starter Web dependency already added for us, and then we also have Spring Boot Starter Test, which is added with all Spring Boot applications. But at the moment, all we really care about is the Spring Boot Starter Web. So if I head into our only package, we'll have the store application class, and this is also auto-generated, and essentially this is going to run our application class. So at the top I'm just going to hit run, or I can hit run from here. And down below it says Tomcat initialized with port 8080, and this is the default port that we have on any Spring Boot application. And now that we've been told that the port is 8080, it means that if we head on over to localhost 8080 within our browser, we'll be able to access some of the endpoints that we have for our application. So I'm just going to open up Chrome. I'm going to head over to localhost 8080 and see what we get. So I've headed over to localhost 8080, and we can see we have this white label error page, which is returned to us when we don't have an endpoint for the URL that we're using. So within our application, what we now need to do is register some endpoints that will return data back to the user whenever they make a HTTP request to us. So within our application, we will typically be registering HTTP requests within a controller class. So if I head back into IntelliJ and stop the application, I'm going to now create a new package which will hold our controller. And within that, I'm going to create a new class called test controller. So our controller class is going to be responsible for handling the different HTTP requests that we make to our REST service. Now there's 4 main HTTP requests that we can make. One is called GET, and that is where we want to request data. One is called POST, where we're publishing data, such as adding into our database. One is called PUT, where we're updating data. And finally, we have a delete request, which is where we're removing data. So to mark our class as a controller, we simply add the annotation at the top of controller. Now, as Spring mentioned earlier, that this application can be used for MVC, the controller class would typically accept a URL, and as a result, it will direct us to a certain view of the application, and that is where the V comes from within MVC. So when our user enters a certain endpoint, we don't really want to return a specific view to them, but we would rather return some data. So rather than having a normal controller which would return a view to the user, we're going to change this to a REST controller. And this is a shortcut provided to us by Spring Boot. By using the REST controller as opposed to the regular controller, when we send requests, the response to our user is going to be in the format of JSON data. Now JSON stands for JavaScript Object Notation. It is a lightweight format of storing and transferring data, and data is typically provided in a name-value pair. And we're going to see in this video how a typical JSON format might be returned to us. Now if we head back into the browser, this request we've made is always going to be a GET request because that is all we can do from a browser. In the later videos when we're making different kinds of requests such as PUT or POST, we're going to use the Postman API, which will allow us to make more specific API requests. But the first API request we've made has been to the home page, which has no suffix to localhost 8080. So I'm going to create a mapping for that GET request. So we would use the annotation of GET mapping. And then within brackets and then within speech marks, we're going to say what that endpoint is. So for us, it's very simply a /. Below that, we then provide a method for the type of data that we want to return. So I'm just going to return a string, and I'm going to call this method getHome, and then very simply I'm going to return the word of home. If I now start my application, and I head back into my browser, we can now see the word home has been printed into our page. And this is the data that we're requesting by going to the very first page. I'm now going to add a new GET mapping for a URL of /test. At the moment, we can see that going to the test URL does not respond anything to us. So I'll create a new GET mapping for /test. And this will very simply return the word test back to the user. And we can see test has now been printed. To very briefly end this video on creating our REST controller and then accessing different endpoints through that controller, I'm going to create a class so that we can see what a typical JSON format might be from our GET mapping. So I'm going to create a class called person. That person has a name and an age, and then we have the getter and the setter for that name and age down below. I'm going to create a new GET mapping, and this mapping is going to return an instance of a person, and the method is called getPerson. So I'm just going to create an instance of any random person, and I've set the person's name as Michael, and I've set their age as 40, and then I've returned that same person. I'm just going to restart the application. And now if I go to /person, we can see a slightly different response within our browser. And this is our very first JSON object that we've created. We can see that it's in quite a simple format where we have the name and then the age followed by an integer, which is 40, and that represents our person. As we add more and more variables to this person, this JSON object will become larger. And if we had multiple people, then we would have multiple braces with multiple values returned to us. And very quickly, if you're wondering how these values are obtained by our Spring application, it is through these getters here. So if I were to actually remove the getters from our person class and restart the application, if I refresh this page, we can see that we have an error, and that is because Spring will specifically be looking for a getter, not even direct access to the variable when it comes to creating that JSON object. So that concludes this video on how we've been able to create our Spring application along with the controller. We've created a few different endpoints so we can see how the REST controller is behaving. And then very quickly we've created this person class just so that we can see what JSON data looks like and how it can be returned to us. In the next video, we're going to look at how we can create a MySQL database. We're then going to populate that database, and we're going to create some more meaningful endpoints that we can then access through our browser for accessing data within that database.